Physical and chemical changes. Learning about chemical changes. Chemical change. A change with which you are quite familiar is the rusting of iron. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance. This substance is called rust, and the process is called rusting. Iron gates of parks or farmlands, iron benches kept in lawns and gardens, almost every article of iron kept in the open gets rusted. At home, you must have seen shovels and spades getting rusted when exposed to the atmosphere for some time. In the kitchen, a wet iron pan, tawa, often gets rusted if left in that state for some time. Rust is not iron. It is different from iron on which it gets deposited. Reaction with oxygen.
The formation of magnesium hydroxide
MgOH twice, which is an alkali, changes red litmus into blue. In general, metals form oxides on combining with oxygen. Water solutions of these oxides are basic in nature. Caution! It is dangerous to look for long at the burning magnesium ribbon. The teachers should advise the children not to stare at the burning ribbon. Activity.
Hold a clean magnesium ribbon with a pair of tongs and heat it over the flame of a burner.
What do you observe?
Magnesium burns with a brilliant light and gets converted into a white solid residue. Collect the solid residue left after burning of magnesium wire in a beaker or glass tumbler.
Add a little water to it and stir the mixture. The following chemical reaction occurs.
In this reaction, magnesium reacts with oxygen to form magnesium oxide. In this reaction, magnesium oxide reacts with water gives magnesium hydroxide. As you have already learned in Chapter 5, magnesium hydroxide is a base. So, magnesium oxide is a new substance formed on burning of magnesium. Magnesium hydroxide is another new substance formed by mixing magnesium oxide with water.
MgO plus H2O gives MgOH twice. Now introduce a strip, each of red and blue litmus papers into the solution. You will notice that blue litmus unaffected, while the red litmus changes into blue, indicating that the solution is alkaline. Activity. Dissolve about a teaspoonful of copper sulfate, blue vitriol, in about half a cup of water in a beaker. Add a few drops of dilute sulfuric acid to the solution. You get a blue-colored solution. Save a small sample of the solution in a test tube. Drop a nail or a used shaving blade into the remaining solution. Wait for half an hour or so. The changes that you notice are due to a reaction between copper sulfate and iron. Change of color of the solution from blue to green is due to the formation of iron sulfate, a new substance. The brown deposit on the iron nail is copper, another new substance. We can write the reaction as follows. Copper sulfate solution, blue, plus iron, gives iron sulfate solution, green, plus copper, brown deposit. The reaction of copper sulfate with iron produced an iron sulfate and copper. Both of these are new substances. Copper was deposited on iron. Activity. Take vinegar in a test tube. Add a pinch of baking soda to it. You would hear a hissing sound and see bubbles of gas coming out. Pass this gas through freshly prepared lime water. When carbon dioxide is passed through lime water, calcium carbonate is formed, which makes lime water milky. The turning of lime water into milky is a standard test of carbon dioxide. Vinegar and baking soda together produce carbon dioxide, which turned the lime water milky. The change in the test tube is as follows. Vinegar, acetic acid, plus baking soda, sodium hydrogen carbonate. Carbon dioxide plus other substances. The reaction between carbon dioxide and lime water is as follows. Carbon dioxide, CO2, plus lime water, CaOH twice, gives calcium carbonate, CaCO3, plus water, H2O. A change in which one or more new substances are formed is called a chemical change. A chemical change is also a chemical reaction. Chemical changes are very important in our lives. All new substances are formed as a result of chemical changes. For example, if a metal is to be extracted from an ore, such as iron from iron ore, we need to carry out a series of chemical changes. Useful new materials, such as plastics and detergents, are produced by chemical reactions. Indeed, every new material is discovered by studying chemical changes. We have seen that one or more new substances are produced in a chemical change.
You saw that burning of magnesium ribbon is a chemical change.
Burning of coal, wood, or leaves is also a chemical change. In fact, burning of any substance is a chemical change. Burning is always accompanied by production of heat. Explosion of firework is a chemical change. You know that such an explosion produces heat, light, sound, and unpleasant gases that pollute the atmosphere. That is why we are advised not to play with fireworks. A protective shield. You must have heard of the ozone layer in our atmosphere. It protects us from the harmful ultraviolet radiation which comes from the sun. Ozone absorbs this radiation and breaks down to oxygen. Oxygen is different from ozone. The breaking down of ozone is a chemical change. If ultraviolet radiation were not absorbed by ozone, it would reach the Earth's surface and cause harm to us and other life forms. Ozone acts as a natural shield against this radiation. Rusting of iron. Rusting is one change that affects iron particles and slowly destroys them. Since iron is used in making bridges, ships, cars, truck bodies, and many other articles, the monetary loss due to rusting is huge. The process of rusting can be represented by the following equation. Iron Fe plus oxygen O2 from the air plus water H2O gives rust iron oxide Fe2O3. For rusting, the presence of both oxygen and water or water vapor is essential. If the content of moisture in the air is high and if it is more humid, rusting becomes faster. Prevent iron particles from coming in contact with oxygen or water or both. One simple way is to apply a coat of paint or grease. In fact, these coats should be applied regularly to prevent rusting. Another way is to deposit a layer of a metal like chromium or zinc on iron. This process of depositing a layer of zinc on iron is called galvanization. The iron pipes we use in our homes to carry water are galvanized to prevent rusting. You know that ships are made up of iron and a part of them remains underwater. On the part above the water, also water drops keep clinging to the ship's outer surface. Moreover, the water of the sea contains many salts. The salt water makes the process of rust formation faster. Therefore, ships suffer a lot of damage from rusting in spite of being painted. So much so that a fraction of ship's iron has to be replaced every year. Information. Stainless steel is made by mixing iron with carbon and metals like chromium, nickel, and manganese. It does not rust. Crystallization. Salt can be obtained by the evaporation of seawater. The salt obtained in this manner is not pure and its crystals are small. The shape of the crystals cannot be seen clearly. However, large crystals of pure substances can be formed from their solutions. The process is called crystallization. It is an example of a physical change. Activity. Take a cupful of water in a beaker and add a few drops of dilute sulfuric acid. Heat the water. When it starts boiling, add copper sulfate powder slowly while stirring continuously. Continue adding copper sulfate powder till no more powder can be dissolved. Filter the solution. Allow it to cool. Do not disturb the solution when it is cooling. Look at the solution after some time. You can see the crystals of copper sulfate. Summary. Changes can be of two types: physical and chemical. In chemical changes, new substances are produced. Some substances can be obtained in pure state from their solutions by crystallization. You have learned about physical and chemical changes in this lesson. That is all.